All right, so this is a video for us to look at to kind of really look at the difference between when you have a no solution equation and an infinite solution equation. So if you look at this slide here, look at all the no solution equations and the infinite solution equations. One thing they all have in common is that the letter terms, the variable terms are the same on both sides. You have an x and an x. You have a 6x and a 6x. You have over here 2x and 2x, 7x and 7x. So no matter what, if it's no solution, if infinite solution, you'll have matching letter terms, if you will. Now let's look at the difference between no solutions and infinite. So in no solutions, the number next to it, once you have it in simplest form on the left and right, is different than the other number next to it. So 10 and 15, 4 and 2. But in infinite solutions, it's identical. So you have 1 and 1, negative 10 and negative 10 for infinite solutions. So using the notes we had the other day, let's see if we can take down some of these notes here. Okay, so looking at these here, let's see if we can kind of put this into a nice little table here. So it is possible to determine the number of solutions of any equation without actually solving it. The number of solutions to an equation can be found after each side has been simplified. So if you look at the table, if you're looking for no solution, you know that um, so for no solution, the coefficients are the same, so same. But what's true about the constants? Yeah, they're different. So let's write down they're different. Okay. For one solution, what's true about the coefficients? Yeah, the coefficients are different. So whenever you're going to get an answer for x, you have different coefficients. So right here, I'll put different. And what's true about the constants? Here and here, they're also different, or they could technically be the same because it would, when that happens, you end up getting like x equals 0, really. Infinite solutions, so same thing. What's true about the coefficients? They're exactly the same. And because they're infinite, identical, what's true about the constants? They're also the same. So this could allow us to actually learn to create equations on your own that would have infinite or many solutions. So if someone came here and said, all right, this is my left side of the equation, and I want to make an equation that has identical, infinite, many solutions. Well, that means you want the right side of the equation to be identical to this. Well, what is this? Let's put it in simplest form. So when you put it in simplest form, you know that 6x minus x is, look at that. There's three terms, 6x minus x and positive 2x. That's 5x here, and then that's 7x plus 4. So now we know that we want this right side to be 7x plus 4 because we want it to be identical. So I'll go ahead and I'll just put, we want it to be 7x plus 4. So we could now go back to the top and say, hey, if you want this to be infinite solutions, you want it to be 7x plus 4. So this would be you just created the equation knowing that you wanted this to equal that. Now, cool little trick here if you wanted to copy this down. So 6x minus x plus 4 plus 2x equals 7x. Now, if we want it to be no solution, we don't want it to be 4 anymore. We could just pick any number in the world. Like, Mac Jones had a good game last night. So we'll make it 10. Now I just created an equation with no solution. So here's a challenge for you. Complete the equation with the values that would result in infinite solution. So what would make this look identical to this? All right, let's see what you did here. To be honest with you, I don't know it off the top of my head. So minus 2x minus 10, combine this with this. You want it to be 2x minus 10. Mac Jones again. So we're going to put here, this needs to be infinitely identical to 2x minus 10. Not bad, right? All right, let's see what it's like if we want to do no solutions. Okay, so again, just to think about it again, no solutions, the coefficients, I don't know how to spell coefficients, coefficients need to be the same. So like 2x and 2x, but the constants need to be different. Okay, so that should be easy. Well, if we want to create an equation with no solutions, let's figure out what this left side is. So this is going to be 6x plus 12 minus x. Combine these little guys here. What's 6x minus x? 5x. All right, here comes the magic. Time to make this have the same coefficient, 5x, but a different constant, So they chose 8. Sure, I could have chose 10. I could have chose 100, if you will. It's still going to be no solution. Why? Because my coefficients are the same, but my constants are different. My coefficients are the same, but my constants are different. So that's no solution. All right, let's have fun with this one then. Can you make your own no solution equation based off of this? Remember, you want the coefficients the same, but the constants different. So clean up that left side and make that work on the other side. Coefficients the same, constants different. All right, so let's see what you did. Negative 3x and 8x, that's 5x. Oops, I didn't even see that. Minus x, minus 6. You got 3 coefficient terms, so that's 4x minus 6. All right, coefficients the same. Pop a 4x up there. Whoops, sorry, it's already 4x. Yeah, that's disgusting. And then instead of minus 6, let's make this the Mac Jones show. We'll put minus 10. Again, it just has to be different than minus 6, and then it'll be no solution. Just to check it, just copy this down quickly with me. Negative 3x plus 8x minus 6 minus x equals 4x minus 10. The equation we just created with no solution. Too easy. Let's just quickly simplify this. We already know where this is heading. This is going to be 4x minus 6 equals 4x minus 10 minus 4x minus 4x. Negative 6 equals negative 10. No solution. Winning. Hopefully this video helps, and we're going to try 10 questions and put on some relaxing ambiance music and see if you can do those 10 questions. But now you can kind of, as you're doing the questions, you're like, all right, is it going to be no solution or infinite solutions? Are the coefficients the same and the constants different? That's no solution. Or are, like over here, the coefficients the same and the constants the same, identical infinite solutions.